So I know before I've talked about the biggest black holes, like Phoenix A, Tom 618, Holmberg 15A, IC 1101, and so on, but I've only mentioned very vaguely, and it's been requested of me very often, to talk about the different types of black holes and a little bit more about them in comparison to how it was described in my first black hole video. And before I have even more people start to heckle or contradict what I say, I will say that these singularities are way too massive to have been created by just one star collapsing, and it is still a mystery how they form. Black holes can eat other black holes, so it is possible that the most interesting ones personally, the supermassive black holes, are made of many small black holes merged together over a very long period of time. And another thing that I find so interesting about them is their density. It is extreme, and with such strong gravitational attraction, not even a photon can escape its grasp. Well, I already accidentally mentioned one, which is the supermassive black hole, so I might as well describe it now. Supermassive black holes are about 1 million to 1 billion times more massive and dense than our Sun, and are found in the centres of galaxies. Most galaxies, and maybe all of them, do harbour such a black hole. So, in our region of the universe, there are about 100 billion supermassive black holes, and, well, as deadly as they sound, and as oversized and far too powerful for us to really comprehend as they sound, they do actually play a very important role in the life of galaxies, even far beyond the black hole's gravitational pull. And the reason that it is so interesting and important is because, well, it's not actually needed for a galaxy to form to have a central black hole, but for some reason every single galaxy does. Well, every galaxy that we have found so far, and it has been theorized that because of black holes creating these things called winds. It's like a jet and an outflow of gas. It spreads atoms throughout the galaxy and can either boost or throttle the birth of new stars, depending on other factors. And that means that supermassive black holes do play an important role in the life of galaxies. And next up is what I would say is the rarest black hole, which is an intermediate mass black hole, also known as IMBH. It is a class of black hole with a very specific mass in the range of 10 to the power of 2 to 10 to the power of 5 solar masses. And just for a small recap, a solar mass is the mass of our Sun. It's significantly more in mass than a stellar black hole, but far less than a supermassive black hole. And one of the theories of intermediate mass black hole formation actually has to do with hierarchical growth. Now, if you would like to learn more about hierarchical growth, I can make a second video, or you could research yourself, because it is a very long and descriptive topic, and I am happy to explain, just not yet. So, looking a little more common and closer to home, there have actually been a large number of suspected intermediate mass black holes detected in dense globular star clusters orbiting our Milky Way galaxy. For example, in 2008, there were a large number of Hubble astronomers that announced the suspected presence of an intermediate mass black hole in the globular cluster Omega Centauri. That kinda sounds like a tongue twister. So now we're gonna go very small to the stellar mass black hole. It is formed from the gravitational collapse of a single star or from the merger of two neutron stars. So, as advertised, stellar mass black holes have masses similar to the masses of stars. And that would be roughly around 3 to 10 solar masses. If the core is massive enough of a star, it will collapse in on itself and form a black hole. Of course, our Sun is much too small or insufficiently massive, if put in fancier terms, to form a black hole, and when it finally runs out of fuel, it will, of course, dissipate that. The odds are these are very abundant, but because they're so small, and of course they're going to be very far away from us, they are very difficult to detect. And judging from the number of stars large enough to produce such black holes, I would estimate that there are as many, like 10 million to a billion in just the Milky Way alone. Now, it is estimated that, the recoil speed limit for a black hole would be maximum around 63 million miles per hour, which is, I think, 17,500 miles per second, or around 1/10 of the speed of light. It is fast enough to circle the planet Earth in 1.4 seconds. Don't be alarmed, though. If it were to travel that fast, it most likely wouldn't go near us at all, and probably wouldn't be able to affect us at all either. So I am running out of time here, but this next one would actually require me to make an entire video about it, and I would be happy to do so if you would like me to. This one is known as a micro black hole, a minimum mass black hole, mini black hole, or a quantum mechanical black hole. It is only hypothetical, but it is a very tiny black hole for which quantum mechanical effects play a very important role in it. The concept of a micro black hole is the idea that there may be black holes that exist that are smaller than a stellar mass, introduced in 1971 by Stephen Hawking. It's possible that such black holes were created in a very high density environment of something like the early universe. Of course, this would drag us to the Big Bang Theory, or possibly through a subsequent phase transition, which is referred to as a primordial black hole. Primordial meaning sort of the first created or developed. Primeval is existing or impersisting from the beginning. You can call it a primordial or primeval black hole, if you will. Sorry, I'm getting sidetracked. They might be observed by astrophysicists through particles that are expected to emit Hawking radiation. If you would actually like me to make more than one video about these kinds of topics, please do let me know. And again, thank you for watching.